Welcome, and thank you for joining us at Actuate 2020, our first ever customer and developer event. While it's difficult to replicate the experience of FaceTime with each other and with our robots, we hope this virtual event gives you a sense of who we are and where we are going. Today, you'll have an inside look into Boston Dynamics from our new purpose-built headquarters in Waltham, Massachusetts. The move comes at an exciting time in our company's history. For most of our 28-year history, we focused on research and development of advanced robotics. But in September of last year, we launched Spot, our first commercial robot. To date, we have leased or sold 282 robots to over 162 customers. I'd like to personally thank each of you who believed in Spot and have joined us on our journey to introduce a new class of mobile robot that reimagines work across a range of industries. Mobility is transformative, and machines that enable us to go where we like have transformed societies more than once. These machines amplify the lives and power of people to do work and to play. Mobile robots have the potential to amplify people in new ways. They will allow us to go into places too dangerous for us, or be instantly present in a location too remote for travel, or persistent and dutiful when we lack patience. For decades, it's been our mission to finally build a robot with the mobility and agility we all take for granted. What takes 2 years for a baby to master, it took us over 30 years to achieve with machines. Spot is the culmination of fundamental advances in robotics that we've developed, tested, and refined over decades of work. But it takes the partnership of you, our customers, to discover and build the applications that will make robot mobility transformational in your industries. Our customers are bringing vision, creativity, and know-how to help us make Spot successful in their world. With this partnership, we are expanding the value of industrial robots and amplifying the role of people in the future of work. When I speak to our customers and developer partners, I detect the spark of excitement that comes from seeing new possibilities in Spot. It's the same spark that led Boston Dynamics to commit to solving locomotion with Big Dog 17 years ago. We've always been fascinated by human and animal movement. Only when you try to make a machine that can move as well as a person or animal do you realize just how sophisticated we are. We realized that to make a machine that could really move, we had to rethink how mobility works. And we naturally started looking at expert movers, athletes. There is common wisdom in that community that great athletics comes from intelligence in the mind and the body. The goal of athletic training is more than getting strong. It's tuning the natural way the body and mind react. Athletic intelligence is the combination of a body tuned to move perfectly with the environment and informed with keen perception and helpful reflexes. We knew we needed to build machines with athletic intelligence to solve mobility. It was a little rough at first. It's humbling to be dreaming of athletic performance when your diligent efforts produce this instead. Even when we started to get smoother walking, making a robot that could remain stable over any terrain was frustratingly difficult. But gradually, over years of effort, enough of the pieces came together that we would occasionally be surprised by the ability of the machine to regain balance. Then we figured out how to generalize the gait of the robot so that we weren't limited to a fixed pattern of footsteps. Once we could place our feet where we wanted and maintain balance, we incorporated perception so that we could step where the terrain allowed us to step. Around that time that we produced this early version of Spot, we felt we had solved enough of the mobility problems that we should commit to launching a product. That opened up a whole new set of challenges. We had to build a machine that not only had high performance, but was affordable and reliable. This was an entirely new set of skills for our company to learn. But at the end of the day, it's just problem solving, and we are great problem solvers. We designed machines for endurance. We tested them to failure. We built new tools that let us automatically download and test new versions of software on working robots. We built tools to support our manufacturing lines. And on August 6th of last year, we shipped our first unit of the Spot product. Spot is the culmination of decades of innovation in robotics and a lot of hard work, learning to build not only machines, but an organization that can deliver a reliable product. We are proud of what we have achieved, but our work doesn't stop here. Spot's next step is to enable more breakthrough innovation, not in robotics, but in your industries. This innovation is made possible by Spot's transformative mobility that allows people to be anywhere and everywhere at the same time. This mobility enables autonomous and continuous data collection to support human decision-making, even in the most hazardous environments. In this sense, the automation that Spot supports is not about replacing humans, but amplifying them, enabling all of us to become superhumans. With superhuman capabilities, the future of work becomes exciting and empowering, a future we want to help usher in. We have been hard at work on this mission to bring innovation to industry in partnership with you. Over the past year, we've had an amazingly diverse set of users prototype and deploy applications built on Spot. Spot has performed inspections at a natural gas plant, an oil refinery, inside a nuclear reactor, at electric substations, and industrial treatment plants. Spot has monitored construction progress on job sites for iconic buildings, airports, solar farms, and has scanned buildings and factories to enable the creation of digital twins. It has checked vital signs of COVID patients, helping to reduce the consumption of personal protective equipment and keep healthcare workers out of harm's way. And much to our delight, Spot has also been on a farm in Australia, herding sheep, on stage with some of the world's top performers, and this summer, a group of Spots performed at a baseball game. Through these experiences, we've learned more about your industries and what it will take for Spot to help you reach your goals. The diversity of applications you are pursuing and the success you've had working with Spot out of the box has been exciting and rewarding for us. We've learned there are common workflows around remote site access and continuous data collection that we can build to make Spot easier to use for all of you. We are improving Spot's autonomy in challenging environments and building tools for collecting and uploading data. We are offering new robot payloads to extend operation and open up new use cases. We're listening to you and building our roadmap to address your needs. Boston Dynamics has had an exciting 28 years of advancing robotics in the lab. But what excites me even more are the years ahead of us working with you to bring our technology out of the lab into the real world to solve problems you face. We cannot do it alone. And I ask you, be bold, put Spot to work, make us work. If we rely on each other and work together, we can introduce a new generation of robotics that surprise and delight us, that amplify our people, and make us safer and more productive. Thank you.
Thanks, Rob. I have to say, watching the development of our robots never gets old. But as Rob said, our journey is just beginning. For the last several years, what gets our team out of bed every morning is seeing our customers use our technology to do incredible things. Just last week, our partners at Unmanned Aerial Systems and Rocky Mountain Unmanned Systems sent Spot into one of the most inhospitable and dangerous places on Earth, or in this case, 9,000 feet below the Earth. They conducted testing for Spot in one of the deepest mines in North America, a 2-hour trip underground, to explore how Spot can help remotely monitor seismic activity and gas to ensure worker safety during operations. This was just one of the several stories about Spot that I hope to tell you more about soon. I often say that I have the coolest job in the world. Prior to COVID, I was on a plane nearly every week. Last June, I was at a high-rise construction project in Japan, an experimental nuclear fusion reactor in the UK, an abandoned copper mine in Arizona, and clown school in Montreal. While our fans on the internet love to see Spot perform, it's clear that our customers have bigger goals for Spot to augment and make their work safer. In the year since Spot has been in the hands of customers, the exploration of Spot's value has fallen into 3 key areas: enabling repeatable autonomous data capture, conducting inspections that are too hazardous for people, and researching new use cases for mobile robots. Let's talk about data capture first. The world's shift to digitalization has driven the need for more data. Capturing data of industrial facilities, construction sites, and remote areas allows for more predictable, efficient, and safer operations. However, traditional forms of data capture can be costly and time-intensive, which makes it difficult to do at a frequency or diversity of data types that keeps up with the ever-changing conditions of the real world. This limits our ability to innovate and automate the lower-value tasks that workers often get stuck with. Spot is changing this by providing a solution for repeatable, autonomous, and effective data capture. In manufacturing, mining, and energy, Spot is being used to scan existing conditions to support the development of digital twins for operations and maintenance. In construction, Spot is being used to automate data capture on job sites to actively monitor progress and to support renovation work. Construction firms all over the world are using Spot to enable various data capture workflows on job sites, giving them access to real-time data on ever-changing site conditions. This data allows them to track, measure, and monitor in real time, supporting on-time and on-budget project delivery. Spot's easy-to-use SDK has allowed construction technologists to build data capture workflows that fit their unique use cases. One example comes from the team at Brassfield & Gorrie. With innovation as one of its core values, self-performing contractor Brassfield & Gorrie is constantly exploring new solutions to address construction challenges. After years of using drones to capture data from the skies, Brassfield & Gorrie was interested in developing an on-the-ground workflow with Spot that included 360-degree video capture of interiors for continuous site monitoring. Through Spot's API, Brassfield & Gorrie built an industry-first workflow to marry their aerial data capture and ground data capture with Spot in a common environment using drone deploy software. Brassfield & Gorrie was able to leverage Spot's SDK to customize the platform for the way that they work, successfully developing both custom software and bespoke payload hardware tailored to the task at hand without any prior experience with developing on terrestrial robots. That's the ease of development we aim to enable with Spot. The value of data capture on job sites isn't limited to contractors. There's an entire ecosystem of designers, subcontractors, owners, and other stakeholders who need to stay connected to construction progress, even when they can't physically be present across a job site every day. Foster & Partners is an internationally renowned architecture firm based in London, known for designing iconic buildings such as Apple's new headquarters. Ensuring construction execution of their design vision is critically important to architects. Foster & Partners recognize the potential for Spot in enabling constant and consistent precision monitoring of ever-changing construction sites to avoid deviations from the architectural design that result in delayed schedules and cost overruns. The Foster and Partners team used Spot in conjunction with integrated 3D laser scanning technology in order to capture and monitor progression of their building at the Battersea Power Station development in London and a refurbishment of their building at their London campus. The data captured by Spot yielded a sequence of highly comparable, consistent models. These models help them track project progress against timelines, as well as facilitate regular comparisons against the BIM model, ensuring preservation of their design intent. While we've designed Spot to be a flexible, customizable platform to suit a variety of needs, we recognize that many of you in the construction world are looking for an out-of-the-box solution for Spot that you can deploy right away. That's why we are thrilled to announce our new exclusive partnership with Trimble. With this partnership, Trimble and Boston Dynamics will collaborate on bringing to market the first fully integrated solution for construction data collection. This solution combines Spot's unique mobility with Trimble's data collection sensors and field control software for turnkey automation of repetitive tasks like site scans and progress monitoring. Trimble's technology onboards Spot for autonomous laser scanning, GNSS navigation, and others coming in the future ensure accurate data acquisition, while Trimble's construction collaboration platform, Trimble Connect, provides a continuous flow of information between field and office. Mortenson, a builder, developer, and engineering services provider headquartered in Minneapolis, is one of the first customers to leverage the competitive advantages of this new technology combination. Mortenson has a strong history of lean innovation and project technology expertise. In this spirit of eliminating job site waste and increasing efficiency, the team has been piloting Spot robots with Trimble's SPS 986 GNSS solutions to autonomously navigate challenging exterior construction environments, such as solar farms, to continuously document existing site conditions and as-builts. This automated and repeatable approach to field data capture can provide Mortenson with real-time awareness of project status, helping to accelerate project delivery to meet construction market demand for renewable energy infrastructure. We are thrilled to be able to extend the Spot and Trimble workflows that Mortenson has been leveraging to you through our new partnership beginning in 2021. In addition to repeated autonomous data capture, our customers have discovered that Spot's unique mobility allows it to conduct remote inspections that remove humans from potentially hazardous environments. With a robot that can go where people go and in places where it's unsafe for people to go, we can keep humans out of harm's way and reduce risk and save on operations and maintenance costs. By allowing humans to conduct inspections remotely, we can not only make their jobs safer, but empower them with superhuman capabilities. Spot allows them to be in multiple places at once, sense and measure things beyond human perception, and withstand environments that are actively too dangerous for our safety. As a result, team members deploying Spot are not required to go into hazardous environments and can use their time to support critical decision-making. In the energy sector, Spot can be readily deployed on autonomous remote visual inspection and sensing missions of substations and power plants. New Brunswick Power, which handles nearly all of the generation, transmission, and distribution of electricity in the Canadian province, got first-hand experience using Spot out of the box for autonomous inspection over the summer. Their Bayside natural gas power plant is an important part of NB Power's power system and helps supply cost-effective electricity to New Brunswickers. New Brunswick Power needed to run the Bayside plant over the summer to meet the demands of their customers. However, they detected an issue with a weld in a high-pressure steam pipe that created a potentially hazardous condition in the plant. If ruptured, the plant would expel 500-degree steam, potentially damaging the plant and injuring anyone near it. Shutting down the plant for a 2-month repair wasn't a good option at the time. New Brunswick Power needed a quick solution that would allow them to continue to inspect the suspect pipe while still running, while keeping human operators out of harm's way. They equipped Spot with a camera and trained it on an auto walk mission of the plant so that Spot could autonomously inspect the plant multiple times a day for 45 days straight, saving humans from performing this potentially dangerous work. Spot's ability to walk under pipes, climb stairs, and walk on graded walkways meant that virtually no part of the plant was out of reach. By keeping the plant running for 45 days until it could be shut down for maintenance, New Brunswick Power achieved a positive return on investment with Spot with this single use case. In this case, the plant operators were able to utilize Spot with just a bit of training support from the company's emerging technology group. New Brunswick Power was able to see a positive ROI for Spot right out of the gate with this single use case. Looking ahead, they have bigger plans for Spot. NB Power operates over 200 remote facilities in its transmission and distribution network, and over a dozen power plants, including a nuclear power plant. Over the next few months, NB Power's emerging technology team plans to work with their colleagues across the company to see how Spot can assist them in their daily jobs, to help them do what they've done for over 100 years, provide New Brunswickers with safe, reliable, and cost-effective electricity. BP is another customer using Spot to remove employees from potentially harmful situations by performing tasks like scanning for abnormalities, tracking corrosion, or checking gauges in remote production sites. After a series of successful mobility and autonomy tests, BP has plans to deploy Spot on one of their offshore rigs for an extended period of time starting this month. The innovation and engineering team sees this deployment as an opportunity for their operators to get hands-on experience with Spot so that they can get a better understanding of how Spot augments their work and makes it even more data-driven. Looking into the near future, BP is also exploring equipping Spot with LiDAR sensor payloads to generate digital twins that enable employees to virtually walk through and examine facilities from safe, remote locations. Once integrated into their facilities, BP envisions using Spot not only for data gathering, but to analyze what that data means and take action if necessary. Over the past years, it's been exciting to see so many customers getting value out of the robot right out of the box, or with simple customization that they are able to do themselves. For more complex use cases, our growing partner network has been supporting customers with the development of new payloads, software, and integrations that help them extract more value from their data. Some of the partners we've been working with most closely have partner booths as a part of this Actuate experience. We encourage you to take the time to visit their pages and learn more about how they can help meet your needs. You've heard about the value of Spot for data collection and removing humans from hazardous work. But some of our customers are getting value out of the robot in ways that are especially captivating. Meet Latte. Latte is a steampunk-inspired character who entertained and delighted visitors at Universal Resorts Orlando in September. Latte joined characters Penelope and Jacques in a first-of-its-kind interactive performance at Universal's Toothsome Chocolate Emporium and Savory Feast Kitchen restaurant. We can't wait to see what the creative team at Universal does next with Spot. So what is next for Spot? Academic institutions all over the world are doing research with Spot and getting students hands-on experience with it. I have no doubt that these talented researchers will extend Spot's capabilities in fascinating ways. What's particularly inspiring is the remarkable research coming out of NASA's Jet Propulsion Laboratory, who are developing high-level autonomy solutions called Nebula. With Nebula, they are exploring Spot's performance in incredibly extreme and remote environments on Earth in preparation for missions as far as the Moon or even Mars in search for life in our solar system. The integration of JPL's Nebula autonomy solution with Spot led JPL to win the latest round of the DARPA Subterranean Challenge in February of 2020. In the competition, Spot autonomously traversed multiple kilometers in less than 60 minutes, produced 3D maps of complex multi-story industrial plants and mines, even 900 feet below ground, and negotiated challenging elements such as mud, slivery terrain, debris, and uneven surfaces in dark, dusty, or variable lighting conditions. Now Team CoStar is researching how these capabilities could be extended to support work on the Moon and Mars. There, Spot could assist with exploration, search for life and future colony locations, and potentially even support astronauts with surface operations and cargo transport. The JPL team is exploring Spot's potential in space by continuing to put it through its paces with real-world complex missions and relevant scenarios such as exploring lava tubes in California that are analogous to caves in Mars. Nebula-equipped Spot robots are pushing the state-of-the-art and state-of-the-practice in large-scale and long-term autonomy in remote and extreme environments, where those environments pose too much risk for people. This is an incredibly exciting time where we are all learning and advancing together. Next year, we'll have even more incredible stories about Spot users deploying robots for life-saving, value-creating work. Now to share with you details on Spot's latest release and near-term roadmap, I'd like to introduce Zach Joukowsky, Chief Engineer for Spot.
Thanks, Michael. When we started the Spot program back in 2014, we set out to answer some important research questions. We thought legs were the right technology to make robots that could work in the same environments people do, but wondered if the technology could really scale to handle practical situations. We had decades of experience making robots do things nobody had ever seen them do before. Over the years, making some of the first, the fastest, largest, and smartest quadruped robots. With Spot, we aim to combine all of our previous research and make a robot that could operate indoors and outdoors, in human-scale environments, on a structured and unstructured terrain. We took the core ideas from Big Dog, combined them with our research from Wildcat, and the practicality we learned from LS3, and made a robot whose capabilities ended up surprising even us. We called it Spot, but that's a long way from the Spot we're talking about today. Our behavior engineering teams took this robot and built our next generation of control systems, going well beyond what we had developed for Big Dog and conquering challenges like stairs and indoor navigation. Over time, we discovered how to build our own custom electric actuators that rivaled the performance of hydraulics. We were able to build smaller, quieter, cleaner, and safer robots. Before long, we overcame the major obstacles that stood in the way of widespread practical applications. Once it became clear that the technology was ready to leave our lab, we started to ask not just, can it be done, but where can we really apply this technology and make a difference? We talked with customers that spanned the gamut of industry, from semiconductors to forestry, and we realized we could equip Spot with sensors and cameras in places where stationary equipment couldn't cover, humans didn't belong, or data needed to be collected repeatedly. Through these initial customer engagements, we began to figure out where these robots could be useful today. In the early days, every new application we targeted required invasive hardware redesign, and robotics experts would have to program new behaviors from the ground up. This obviously couldn't scale to the range of applications we wanted to apply the technology to, so we focused on building a platform, a common piece of hardware that we could mass produce at reasonable cost and develop good reliability on. High-level interfaces that would let application experts stay experts on what's valuable instead of learning the details of robotics themselves. Through these years of development, we've refined Spot to be the robot you know today. A robot that navigates terrain with unprecedented mobility and provides a polished, operator-ready experience out of the box, all with a flexible, customizable platform that allows you, our customers and developers, to easily outfit it to support your applications. This past year, we've begun to distribute Spot and put it to work on your sites. Your feedback as customers, developers, and designers has been a strong guide for us. We learned that valuable solutions require both strong mobility and strong autonomy. A wide variety of interesting applications take place on construction sites. Construction sites change all the time. If they don't, that's a problem. Changing sites also defeat many state-of-the-art robot localization and navigation methods. We saw this and immediately put our efforts into new techniques for robot localization in these challenging environments. Our latest update of AutoWalk incorporates these improvements, expanding on its out-of-the-box functionality in the tablet and making it dramatically more reliable. Beyond that, we learned that autonomy isn't enough. Many of the applications we're excited about center on collecting valuable data around facilities and work sites. To make Spot a truly autonomous data collection tool, it needs to recharge itself without human intervention and have interfaces that allow operators to intervene from afar. Let me show you how all of these pieces are coming together over the next few months to fulfill this complete solution vision. First, we'd like to introduce our newest software release, Spot 2.1, which will be made available in the next few weeks. 2.1 is all about bridging the gap between Spot as a developer platform and Spot as an operational tool. We've analyzed the most common developer workflows and made it easy for you to do the 3 things you need to do most. With 2.1, you can attach sensors and collect data that your team needs, more easily build AutoWalk missions that use them, associate metadata with your sensor, and store and download outputs for off-robot data analysis. Let me show you how, in just a few straightforward steps, you can now deploy Spot for a full visual inspection workflow. First, you might equip Spot with a payload, like a Spot cam or an off-the-shelf sensor like a hyperspectral imager. While Spot cam comes integrated, we have example code that makes it easy to add a variety of your own sensors. Once a sensor is integrated with Spot, the camera feed is automatically pulled into the robot's data acquisition system, or DAC for short. We've also added a new service on Spot called the Data Buffer that makes it easy to store your sensor data on the robot. Now you don't need any extra infrastructure to build a complete solution. One of the most important lessons we've learned from you this year is that sensor data itself is great, but what's really useful about a tool like Spot is the ability to tie sensor data to indoor location data, including where the robot is pointing. Tag what you're looking at for later analysis, and then repeat that collection operation repeatedly. 2.1 brings that functionality to AutoWalk and makes it easier to trigger and point both SpotCam and your custom sensors. The DAC service works to retrieve that rich data from the robot and pair it with the images you see in the tablet view. When a mission is complete, the operator can download all the data to the tablet controller and send it to be processed by the rest of the data pipeline, plotted, or integrated into an existing piece of your infrastructure. We expect this new release will unlock additional deployments and jumpstart development work, but that's not all we have in the pipeline. While our Explorer Spot has served to introduce innovation teams to developing on the robot, we've already identified a number of system upgrades that users looking to deploy Spot into scalable applications will benefit from. This upgraded enterprise version of the robot will be available in early 2021. Enterprise Spot comes with hardware enabling it to self-charge, along with an upgraded CPU that makes it ready to receive even more powerful perception and autonomy algorithms as they're developed over the coming years. When paired with the new self-charging dock, Spot can function for prolonged periods with no human interaction. This makes it possible to work in dangerous environments, like those with radiation hazards, or remote facilities like offshore oil rigs or electrical substations. We've designed the docking and charging behavior to be simple and reliable. Without operator input, Spot recognizes its charging dock and performs the docking maneuver autonomously once commanded. Docking is as easy as tapping a fiducial on the tablet or our new web browser interface, which I'll cover next. When docked, Spot can both charge and offload bulk data over a gigabit Ethernet connection. Beyond persistence on a site, docks can be used as breakpoints in long missions. In many Spot configurations, mostly dependent on how much power payloads are drawing, docks can be placed 5 kilometers apart and chained to enable missions of any length. In addition to self-charging, we'll be launching new control interfaces for Spot designed around serious operationalization of industrial inspection applications. Starting in December, this will include browser-based interfaces for teleoperation and later complex mission planning. Using an on-premises server to provide a secure, persistent connection point for your fleet of Spots, these powerful, large-screen user interfaces, in addition to the existing tablet, will make it easy to operate your robot from anywhere you have a network connection. This will make it possible to enjoy the benefits of software as a service platforms, like serving the user interface for Spot to any client on the network without pre-installing it, with the strict data security requirements of many of our industrial and utility customers. With the dock, SpotCam, and these new web interfaces, we'll have a complete out-of-the-box solution for teleoperation and automated data collection in industrial facilities. What we've presented so far today has hopefully convinced you that Spot is a robot with unprecedented mobility, ease of use, and customizability that will soon be a complete solution for autonomous industrial sensing tasks. Naturally, as roboticists, we ask, what if the robot could do more than sense? What if it could interact with the world around it, manipulate doors and objects found in common work sites? In early 2021, we're bringing the ease of use we brought to legged robotics to manipulation. Here at Actuate, for the first time ever, you're seeing a production Spot arm in action, with 6 degrees of freedom, plus a gripper and full dynamic behavior integration with Spot. The arm is designed to move and balance with the robot while facilitating a large range of motion. Like the base robot, there's much more to the arm than just hardware. It will ship with an intuitive user interface and be equipped to operate through both teleoperated and supervised autonomous behaviors via the tablet. Like the base Spot, the arm will come with an initial API support. This includes basics like end effector control in Cartesian space and individual joint control. But what we're really excited about is advanced capability we're offering, such as automated grasping, locomoting to follow end effector commands, door opening, and dragging objects. These advanced functions will initially ship as beta features, which will robustify and expand upon with future software releases, forming a rich library of manipulation behavior primitives. Let's talk a little bit about the tablet integrated behaviors the arm will ship with. When we say supervised autonomy, what we're referring to is tasks that take a little bit of input from the operator, but then proceed using the robot's own perception and reactive behavior. In the case of opening a door or a cabinet, the operator tells Spot where the handle is, but from there the robot will act autonomously, figuring out whether it's a push or pull and how much force it takes to open the door, all by itself. Fixed robot arms have developed to include amazingly intuitive and fluid user interfaces. That's not the case for mobile robot arms on the market today. We've made it a priority, just like with the rest of Spot, to make it intuitive to command the arm to do what you actually need to do, and the robot's smart enough to take it from there. Spot arm behaviors don't have to be programmed by a roboticist. With easy clicks and swipes, a plant operator can use the arm to grasp, carry, push, and drag objects in novel situations. As excited as we've been to introduce the world to the possibilities of legged robotics, we're that much more excited to do so with mobile manipulation. Initially, we said that Spot as a sensing platform could give the computing revolution the eyes it needs in the real world. The arm adds the tangible manipulation piece to that. With the arm, Spot will finally have the ability to act on data insights and start performing real physical work in human-centric environments. Turning valves, throwing switches, retrieving items, clearing debris. We think the possibilities are limitless with this added capability. Robots have come a long way in the last 10 years, and Spot has come a long way in the 12 months it's been commercially available. We're going to keep working toward our goal of making Spot even more capable, intelligent, and useful in the real world. We've prepared a series of breakout sessions to teach you about the many parts of the Spot platform and its applications. Join these sessions to learn from our team's technical experts, our customers, and partner developers on how to make the most of Spot's capabilities and our new release in your development and operations. Following the breakouts, we'll see you back here with one last keynote where Mark Raber will give you an exclusive look inside our Atlas lab with a new live Atlas demo. Don't miss it.